And welcome to the Daily Space Weather Show. Multiple coronal mass ejection events headed this way. And what can I say? If you heard it first on our channel, congratulations on realizing it exists. That's the past 24 hours on ionized helium from Solar Dynamics Observatory. And right there, where you see a large M-class, nearly an X-class flare, right in the Earth-facing portion of the solar disk, there was a massive CME associated with that solar flare, a coronal mass ejection, where the sun blasts off a bunch of material out of its corona, the sun's atmosphere, and headed this way. Here's 171 angstroms, the house favorite classic wavelength from Solar Dynamics Observatory. My personal favorite. Make sure you let us know in the comments what your favorite SDO wavelength is. And before we look at some more solar imagery, let's take a brief look at what's going on planet Earth. First, volcanoes. These are the erupting issues at the moment. Ibu, exploding. Luotobi, producing some new real estate and a pyroclastic flow. What about Semeru? Volcanic ash reported there. Also Merapi, 12,000-foot ash plume. Popocatépetl, 20,000-foot ash plume. Santiaguido, Fuego, Nevado de Ruiz, and Sabancaya, all erupting. Next, earthquakes. And I don't know. If you think there's an earthquake risk on the west coast of the U.S., let us know. And, but anyway, here's the report of 5 and greater magnitude quakes. We're having a bit of an earthquake drought here once again. We are due for a large quake for sure. And these are the quakes of 5 and greater magnitude. New Zealand, in the Kermadec Islands. They're in between New Zealand and Tonga, adjacent to the Kermadec Trench, of 5.0 at 12:49 Universal Time this afternoon. Myanmar had a 5.0 at 20:48 this evening Universal Time, and Chile had a 5.4 at 21:04. Next, some more solar imagery. And that ain't half bad. Yeah. Now we've got 171 plus 131. 2 species of ionized iron. Those wavelengths are great at showing active regions, solar filaments, magnetic field lines, and to a lesser degree, solar filaments. Now you may see that filament eruption there. It kind of made its way off to the north, but some of that material is off toward Earth. Sunspot 3576 remains the most active sunspot, or T-mass. It's our T-mass, the most active sunspot. And there it is. Great view of Sunspot 3576, as it continues to be one of the most interesting sunspots to date in Solar Cycle 25. There you can see that plasma making its way off to the north as some splashes back down, some blasts back off, out into the greater solar system. And let's continue on here with some space weather stats. First is the 10.7 centimeter radio flux, which is now at 180 solar flux units. 180 is the radio flux. There's the 1-year graph. It's represented by the black line. As we inch closer and closer to solar maximum, give it another 8 months, which means you can expect 16 months of similar activity to what we have now. Here's a space weather enthusiast dashboard, and as you can see, geomagnetic unrest forecasted for a brief period later today. I mean, really for right now. Of course, a quote, unexpected CME showed up. Yeah, an unexpected one, folks. It was, nobody expected it besides people that watch our channel. So, I mean, what can you say? What can you say? Facts, still controversial in the year 2024. So yeah, and then Monday night into Tuesday night, even into Wednesday night, geomagnetic storm conditions coming for days. So we could have even higher levels than this. It all depends on the magnetic field. It all depends on the magnetic field strength and orientation and the plasma temperature and the plasma density and the plasma velocity. So there are a lot of variables here, not necessarily well modeled. And let's move on. There's the Enlil spiral, and expecting 2 impacts there on the 13th. The one from late in the day yesterday expected to arrive late in the day on the 13th, and so on. I'm not going to get into rehashing stuff that I already said. There's NASA's forecast, expecting only a big spike late in the day on the 13th. So once again, a very different forecast there by NASA and NOAA. Kind of weird here, the past 4 hours of Earth's magnetic moment from space, and it's somewhat active as we have a high-speed solar wind. We still haven't seen the subsiding of the most recent CME impact. So that's still coronal mass ejection material there, folks. And since it refreshed, we'll let that play through. So that depicts magnetohydrodynamic pressure, the units of which are nanopascals. And yeah, Earth's magnetic moment from space for the past 4 hours. And if you're wondering what's behind me, it's the constellation Cygnus. Interestingly, the strongest point in the entire night sky, in the entire sky period for radio flux, as well as the only known cosmic ray point source. Anyway, there's Earth's magnetic moment from the ground for the past 4 hours, our ground magnetic perturbations map. This depicts magnetic flux density from the ground level in nanotesla magnetic flux density. Geospace delta B refers to changes to Earth's B field. And aurora likelihood continues. KP index at 1.67. KP 1.67. It's geomagnetically calm despite the elevated solar wind velocity. So here's the ACE, and the ACE isn't showing nearly as good of a signal there as the Discover, although it did register up to about, well, over 12 protons per cubic centimeter. And let's switch to the Discover. There's the Discover, and much better signal there, having made it up to about over 40 protons per cubic centimeter, almost 50 actually for a brief period. The leading edge of that CME impact there's a 46.99 reading. But the most interesting part was right around here where the field got all the way up to 18 nanotesla with a BZ of negative 11. So that was optimal for geomagnetic unrest conditions, although they subsided rapidly as the BZ made its way back toward positive territory and the magnetic field weakened. So plasma speed made it all the way up to 630 plus, 650 about. So quite a fast CME impact there, and it is still coming with a current solar wind velocity of 570 kilometers per second, solar wind density about 7.3 or about 7.4 protons per cubic centimeter. So there you go. GOES magnetometers are not very perturbed by that impact, but you do see some sawtooth readings there, as you may come to expect from watching the channel. There you go, CME impact. So variations. The day before, this one over here, that's a coronal hole impact, and the one over there, that's a CME impact. So that's the GOES magnetometers. Next is our top view ecliptic plane field plot. So Earth remains in a North Pole sector. As you can see here, no sector boundary crossing likely for days. Oh, now wait a minute. Let's take a look at that again. Did I see a rapid acceleration of the South Pole sector? Indeed I did. Look at the last image. So it could only be 48 hours away. Maybe less. Depends on if it keeps accelerating, but it looks like it did slow down. Let's play that through one more time. I slowed it down a little bit slower than normal. There you see that acceleration there, indicating some changes going on in the eastern limb region, I'll say. So here is our line of sight field plot. And we did see some coronal holes open up yesterday, right after that coronal mass ejection and large solar flare happened. You'll see great imagery of that in the 211 angstroms wavelength There's our coronal hole line of sight plot. And indeed, some coronal holes opened up right around here. Well, let's just switch to the SDO imagery. And right up here to the north and the northwest of sunspot 3576. Right after the flare, you see some coronal holes opening up. So this is a thing that happens sometimes, and there's a great example of it. It did largely close back up again. So a brief period there when some coronal holes opened and then rapidly slammed back shut. So anyway, next is our sunspot information, and sunspot number here is just under 150, so I'll say 148. 148 sunspot numbers. Sunspots is the sunspot number according to Rob, the Royal Observatory, Belgium. So there you have that. Here's our flare probability monitor and scoreboard. Oh, first the synoptic map. And a pretty well-defined coronal hole of North Pole orientation down here. And lots of filaments. Check it out. Filaments. 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 Prominences are also filaments. So, yeah, lots of prominences. Lots of filaments. Likelihood of coronal mass ejections remains nearly 100% going into tomorrow. Here's our flare probability monitor and scoreboard. And sunspot 3576 still poses a risk for significant flares, but we've also got some northern groups now chiming in, like 3583 is magnetically complex. 3581 has some potential. 3582 has some potential. Also, we've got setting groups on the western limb, so that raises the likelihood of flares as well. Here is SDO magnetogram to see most of those established groups fairly stable here since yesterday. That's the past 24 hours. And there's continuum. So that's sunspot group 3576 there, south of the Earth scale. That is probably like over 100 sunspots in one group. It remains quite impressive indeed. Continuing right along, the radio blackouts here caused by the attenuation of the D layer, those are starting to subside, so an indication that the proton flux is returning to baseline levels. Just keep in mind that if we do have another large solar flare event, the likelihood of more proton events remains, because just the fact that a CME impact is currently happening, that means a magnetic channel's open. So yeah, so we could see more proton events, but at the moment they are subsiding, as you can see from that deabsorption region animation. Most of the northern polar radio blackouts here are just about gone, turning into brownouts as we create the video. So there you can see the proton flux there. The 10 mega electron volt red line is just dropping back into levels below the warning threshold. But still some protons there. So there you go. I don't know. There's the data. Cheers. And here's the flare that was associated with the last earthly directed coronal mass ejection, I think. But there have been enough in the past 24 hours that it's going to be a little bit tough to sort of get a bead on them all. You'll see what I mean in a moment. Before we get to any star charts, let's take a look at the 94 plus 131 angstroms wavelengths from SDO. So yeah, besides that nearly X-class event from sunspot 3576, things have been quite calm. So it's easy to conclude that for the last 24 hours, the T-mass is sunspot 3576. It's been a star within a star, if that makes sense. And I'm sure it does to all of you well-informed, intelligent viewers. If you're a content creator and you're watching this video, never assume that your viewers are dumb. That would be a dumb idea. Anyway, this is what's going on overhead. As the sun is setting, we're coming out about an hour earlier than normal tonight. It is Sunday night after all. We've got a little tiny sliver of a moon and Saturn all trailing the sun across the ecliptic. Also Jupiter. Much higher in the sky if you're viewing the early evening sky. That bright object up there is the largest planet in the solar system. Next, our solar system forecast. So, we'll show you where things are today, ta-da, and then where things will be in a week. And in 1 week, we will have a gibbous waxing moon as we approach the February full moon. Next, our astronomy photo of the day, but first, a hilarious YouTube channel. They idiotically named their channel the Grand Solar Minimum Channel. Now, talk about painting yourself into a corner, folks. I mean, could you possibly paint yourself into a more cornered corner than naming your channel the Grand Solar Minimum Channel? Now, I would not encourage you to go over there and leave a comment, okay? Because I did this yesterday. I attended the live stream for about 2 minutes, and I said, is this channel still forecasting a Grand Solar Minimum? And guess what? I didn't get a response. You know why? Because my comments were getting deleted a few seconds after they were getting placed. So the most hilarious part is, check it out, the most heavily censored GSM channel on something. Like, okay, you're so heavily censored that you censor your viewers. That's science-y. Well done, Jake. Well done. Mwah. It's the epitome of sound science, having to delete the comments of your own viewers. Well done. Anyway, don't tell any of the Grand Solar Minimum cultists that cosmic ray flux can be expected to continue to drop for another 20 months, but it can, since cosmic ray flux is known to lag solar activity for like 5 months. So yeah, definitely don't tell them that. They'll be very sad if they find out the cosmic ray flux is slated to continue to decline. Keep in mind, it is at the lowest levels in 20 years. Yeah, cosmic ray levels are at the lowest levels we've seen since about 2004. So anyway, let's do a brief update here for the past 30 days. We do it like once a week on the channel. And there you go, a Opacity neutron monitor showing flat levels over the past 30 days. Maybe a tiny uptick there. Basically flat. Barentsburg, slight shade up at Barentsburg over the past 30 days. Again, expect cosmic ray flux to continue to dip for like 20 more months. Athens neutron monitor not looking so good, but looking almost flat for the past 30 days. Mexico City, a tiny shade of an uptick, almost flat for the past 30 days. Oulu neutron monitor, almost flat for the past 30 days. Again, I would cite this right here. You see that line? Whoops, that goes all the way back to 2004, folks. 2004 is the last time we've seen cosmic ray flux as low as it is in February 2024. Let's look at Antarctica's monitors as well. There is DOMB showing a downtick for the past 30 days, and there is DOMC showing a slight uptick for the past 30 days. So basically flat levels for the past 30 days at the world's cosmic ray monitors. Next, the astronomy photo of the day. There you go. That's pretty sweet, right? Now, if you're wondering what that is, that's the full moon. That is a 2001 launch of the Space Shuttle Atlantis, and that, having launched right after sunset, is the rocket plume's shadow, which just happens to be in line with the sun from the photographer's perspective. There you can see the sun shining on that rocket plume there up by the mesosphere or wherever it happens to be. That's the apod.nasa.gov astronomy photo of the day, apod.nasa.gov, and let's move on to CMEs. CMEs, there have been a lot of them in the past 24 hours, so check it out. DAG. And we've only got 57 frames, unfortunately, but quite a few events happening there, including at least one more that's earthly directed, or that includes earthly directed components, I'll say. Most still will miss to the north, but, well, you'll see here in a moment. So here, let's just zoom in a little bit closer. There we go. So that one coming out of the north just after midnight local time this morning on February 11th is indeed containing earthly directed components. It came from an area right near the solar equator, right in the Earth-facing strike zone. So perfectly earthly directed solar flare almost. I mean, the flare was kind of right in the center of the solar disk, very close, just a little bit. Well, anyway, you saw it. We showed it. So let's just look at stereo A here as well. So we've just got the difference imagery on the right and the raw coronagraph on the left. Exciting times for space weather. And let's take a look at our custom coronagraphs next. These are 24-hour videos. You've got SDO 304 angstroms and then LASCO C2 and C3 synchronized there to the extent that we have data from them. So now it looks to me like only one of those CMEs has an earthly directed component. It's the first one, right at the beginning of the video. And when we zoom in, you'll see exactly where it came from and see why it's so likely that it has significant earthly directed components. So right in here, you'll see darkening. That is the absorption feature of that plasma exiting the solar corona. But just because it's so perfectly in the Earth-facing portion of the solar disk, we anticipate that even though most of it likely to miss to the north, some of it likely to strike the Earth. As far as the rest of those events, the rest of those don't look earthly directed. So as we get closer in, you'll be able to see here we've added 193 angstroms to the SDO imagery to add a little bit more contrast. So yeah, that's pretty sweet. And here's an even closer zoom of that. So that's what's going on. That's the latest CME to be on the way to strike Earth late in the day on the 13th. Next, filaments. And yeah, there's Cerro Tololo's ground-based solar observatory. Lots of filaments. Likelihood of coronal mass ejections remains nearly 100%. Now remember, folks, this year is the year of the dragon in the Chinese calendar. And consumer tip, never try to sneak up on one in its lair. Dragons aren't surprisable in their own lair. There's a 0% chance of success for that. So, just a little fun fact from a dungeon master. Yes, I wear many hats, both literally and figuratively. Look at all the filaments. Let's move on to get to our bonus features segment. So, again, pretty quiet since that nearly X-class flare late last night. And here come bonus features. First, satellite charging hazards. We ain't got none. Electron flux, kind of low. Yeah, satellite charging hazards, non-existent. Electron flux, a bit on the low side. I mean, CME impact is happening, so no surprises there. There is the one-year graph from Solon.info. Yes, Solon.info. There's the forecast from NOAA, and I don't care. That's what it is. Next, the ionosphere. So here it is. There's a some imagery there, and just a quick reminder, folks. Did you realize that the thermosphere is hotter up here and colder down here, and the mesosphere is colder up here and hotter down here, and the stratosphere is hotter up here and colder down here, and the troposphere is colder up here and hotter down here? Yeah, it's called temperature inversions. That's why this line is wavy. See that? That's temperature. And yeah, just a little consumer tip there as we get closer and closer to meteorology from our space weather segment. The F layer, it's at about 300 kilometers of altitude, and here it is. There it is, the ionosphere. There it is, the anomalygram. And not a lot going on there, so it's not super exciting here, as it's been a pretty minor impact of space weather. We only got the geomagnetic unrest conditions in the past 24 hours, so not a whole lot of anomalies showing up there on the map. Next, the whole atmosphere model. Looking at total electron content on the left and maximum usable frequency on the right. And the final section of space weather is for high-res imagery. So there you go. We'll briefly look at 3576. It has indeed been degrading. Whoops, there we go. It's still beta gamma class? Beta gamma delta? Yeah, barely. Anyway, let's take a look at the fields of some of these other sunspots here as well. Especially these two. Pretty impressive. This one here, pretty impressive too. Complex magnetic fields there, more likely to produce large solar flares. These are looking pretty weak. Not too exciting. Yeah, so most likely place for a large flare, still probably this sunspot, but we've also got these two now getting in the swing of things, and also we've got two more likely to rise here in the east. So those possibly could produce large flares as well. A little bit too early to see their magnetic configuration or their umbre. So anyway, there's a disk. And here comes meteorology. We're starting out with surface winds over the U.S. because there's some rather significant weather happening there. So there you go, the surface winds of the U.S. right there, as there is a low over Texas. And you can see a bunch of lines. It's a bit of a choppy low. It's not particularly well organized. Anyway, these are the surface winds of the east. Jet streams are next. Jet streams of Europe, Africa, and the Middle East. Surface winds of the west, and the jet streams. Still a bit of a weird jet stream here over North America. It's very far to the south in the Pacific Ocean there, and that's just what's going on. Anyway, clouds and fog are next. Satellite-based shortwave radiation map depicting clouds and fog, even when it's too dark for the visible satellite. We'll look a little bit closer at that low we showed you over Texas. Man, that low pressure moving from New Mexico into Texas is enough to make you want to enjoy a sody pop. Right, Smash Staff? Smash Staff loves drinking sody pop on Sunday in Texas. Nothing better than a nice frosty sody pop on Sunday in Texas. Texas. Go ahead, say it aloud, I dare you. Texas. You too can annoy someone by talking about sody pop in Texas on Sunday. Check out our precipitation type. There's snow falling in Texas. That's our precipitation type map, and there's some snow, some wet snow, and some rain with snow and things occurring there. So yeah, that's our precipitation type map. And if you don't like it, then you still have to press the like button, or your soul shall be pulled into an ever-deepening and darkening abyss of doo-doo, diarrhea, and kitty cat vomit. So press the like button. You don't want that stuff. Are you a sociopath? Press like. Leave a comment and tell us why you're so mad that we've asked you to press like. If you can't be arsed to press like, we can't be arsed to care what your comment says. Cheers. Just kidding, folks. We read all comments. Anyway, here's our weather.gov map, and we've showed you the key, and then the page jumped because reasons. We apologize if we've induced any epileptic seizures by suddenly zooming. We've got some severe weather and some flood alerts and some winter storm warnings. Here comes some forecasts, starting with the GFS 72-hour pressure and precipitation forecast. That's what it is, yeah. And some heavy snow is going to make its way across Arkansas and Missouri. I wonder what if there are any great brands of sody pop you can get in Missouri that you can't get anywhere else. Anyway, there's a 72-hour GFS pressure and precipitation forecast. Next, our total accumulated precipitation forecast. And look at the heavy rain totals in Georgia, South Carolina, and North Carolina especially. North Carolina, South Carolina, and Georgia. They're going to get kaplastered with like 4 inches of rain. Cheers. Next, our total accumulated snow depth change. Our positive snow depth change in inches forecast. GFS 72-hour model. Some snow coming for Texas and Oklahoma and New Mexico and Arkansas and Missouri. And anyway, there's the map. I'm not going to try to describe it. What the hell's the point of that? Anyway, here's our temperature anomaly forecast in degrees Celsius. And the heat wave in the eastern portion of the country is finally ending, although it's not ending in Minnesota. It's going to remain quite warm in Minnesota. West of the Rockies, a little bit anomalously on the cold side for the most part. Anyway, there's the forecast. There's the map. That's why we show it. Why am I trying to describe it? Here's lightning. And yeah, we've got some terrestrial strikes here going on. Some terrestrial strikes over the past 10 hours. Let's take a closer look. And we saw some severe-looking storms there. Yeah, we do have some severe storms. Check it out. Mississippi-Alabama border region. Also, western Georgia. Those are the strongest ones, but also Louisiana's got some incoming thunder. I'll bet there's some killer gumbo around those areas. Man, that looks swampy. Anyway, there's the full map, lightningmaps.org. Next time you hear thunder, check it out. Convince your friends and foes that you're Zeus or Thor or something. So here are those strong storms, and you could see some damaging wind and hail associated with these, possibly even some tornadic activity. That one that's just east of Montgomery right now is not looking optimal for those in the path. And Atlanta could expect to see some severe thunderstorms here in a little while. But it's not right in the crosshairs, as those systems make their way directly toward me. That moisture will continue. It's the atmospheric river from the Pacific. Once again, the Pineapple Express. There's the full 50-state view. We'll focus on the lower 48 view. That's Doppler radar. That's clouds and fog. And that is water vapor. Now, I'm not going to close out the video without giving you a Super Bowl forecast. So here's the forecast for the Super Bowl. The Super Bowl is going to finally end in quadruple overtime with a safety. Final score is going to be 0-2. Or it might be 2-0. I don't know who the home team is, but 0-2 is going to be the final score. And the San Francisco 49ers shall be the Super Bowl champions. Anyway, see you soon. It's been a delight, as always, being your host, Dan, a.k.a. Smash-O-Mash, but I'm signing off, and in the meantime, like until tomorrow, may that solar wind be at your back. I'll be back in the bunker again. Whoa!